For the last decade, the whole story of AI has been pretty simple. Bigger is always better. More data, more GPUs, more parameters, you name it. But what if that's the wrong race to be running? In this explainer, we're going to dig into a totally new vision for AI, one that's all about efficiency, not just sheer size. Let's get into it. And that right there is the big question. It really challenges the main assumption our entire industry has been running on. Instead of just adding more horsepower, what if we need to redesign the engine itself? The idea here is that the path we've been charging down, yeah, it's given us some incredible stuff, but what if it's just fundamentally wasteful? And this analogy just perfectly nails the problem. Think about it. When you ask one of today's big language models a simple question, the entire massive network, we're talking billions, sometimes trillions of parameters, fires up just to process it. It's an incredible picture of the inefficiency we're dealing with. All right, so let's really get into what this whole brute force thing is all about, and why, even though it's gotten us as far, it's starting to cause some serious headaches for the future of AI. The engineering culture in AI today is pretty much built on one core idea. The basic thinking is, hey, if we just keep throwing more at it, more compute, more data, bigger models, real intelligence is just gonna pop out at the end. This bigger is better philosophy has been powerful, for sure, but we're starting to hit some very real walls, both in terms of cost and energy. Okay, so if that's the problem, what's the solution? Well, there's a new philosophy emerging, one that takes its cues from the incredible efficiency we see all around us in biology. It points to a totally different way forward. And this really lays out the two paths we can take. You've got the brute force way, which is all about horizontal expansion, and then you have this vision for efficient AI, which is about making the algorithms themselves smarter, adding structure, and focusing on a totally new way to measure success. How much intelligence do we get for every single joule of energy spent? It's a fundamental shift from raw power to smart design. And this is where we meet the hero of our story today, a proposed architecture called Echo, which is built from the ground up with this very idea of efficiency at its core. So, what does Echo stand for? It's Efficient, Contextual, Hierarchical Orchestrator. I know, it's a mouthful, but the name actually tells you a lot. It's not trying to be one single giant brain. It's designed to be more like a cognitive ecosystem, where lots of different parts have specialized jobs and they all work together. And that modular design, well, that's the secret to its efficiency. And honestly, here's the best way to wrap your head around it. Forget the image of one giant, all-knowing network. Instead of that, picture something more like a boardroom, a council of experts. Each one is a top-notch specialist in their field, and a central planner only calls them in when their unique skills are actually needed. So, who's actually on this council? Let's do a quick meet and greet with the key players, the modules that make up this ecosystem. All right, here's the whole crew. You've got Sentinel doing triage at the front door, Atlas handling the core language, Guild acting as a bank of experts, and a few others. Together, they create this whole layered system for reasoning. We're not going to go through all 7 right now, but let's zoom in on the first 3 to really get a feel for how this whole thing works. First up, you've got Sentinel. I mean, think about it. In any big company, you don't send every little question straight to the CEO, right? You've got a front desk, a gatekeeper, to sort things out and direct traffic. Well, for Echo, that's Sentinel's job. So Sentinel is this small, super efficient little network that first looks at any question you ask it. It asks, okay, is this just a simple chat, or is it a heavy-duty math problem that needs a lot of brain power? And based on that, it assigns a compute budget, deciding just how much of the system's resources this task is worth. And just that first step, that simple sorting process, saves a ridiculous amount of wasted energy. Okay, so once a task gets the green light, it often heads over to Atlas. Now, don't think of Atlas as this huge library of facts. It's more like the grammar engine for the whole system. Its main job isn't to know everything, it's to understand and build language fluently, and to be the coordinator for all the other modules. It's the core of the system, but it's deliberately kept lean and efficient. But okay, what happens when you need a real expert? Something like advanced calculus or writing a piece of code. That's when Atlas knows to turn to the Guild. You can think of it as a huge library of specialists ready to be consulted. Okay, and this is where the whole design gets really smart. The Guild could have hundreds of these expert networks inside, giving the system access to a massive amount of knowledge. But, and this is the absolute game changer, for any single task, a special routing mechanism only wakes up 2 to 4 of the most relevant experts. So you get the power of a monster model, but you only pay the tiny energy bill of a small one. It's the best of both worlds, huge capacity without the huge cost. All right, let's pull back from the technical details for a second. What does a huge shift like this actually mean for the future of tech? Well, the implications are massive. It could be the start of what some are calling the post-compute era. I mean, we've seen this movie before, right? We had these enormous mainframes that filled entire rooms, and then came the personal computer. We had giant, expensive supercomputers, and then came flexible clusters of cheaper machines. It feels like AI is heading down that exact same road, moving from this brute force era to a new one that's all about elegant, clever efficiency. So, at the end of the day, the new goal is super simple: getting more intelligence for every single watt of power we use. And look, this isn't just some abstract engineering problem. This is about economics, it's about the environment. It's what could make really powerful AI available to everyone, not just the handful of companies that can afford to build these gigantic data centers. And this really gets to the heart of it, the deep principle behind this whole idea. Real intelligence, whether it's in a human or a machine, isn't really about brute force. It's about being economical. It's about knowing exactly what to pay attention to, and maybe more importantly, what to ignore. It's all about selective attention applied at the right time with absolute precision. Which leaves us with one final, really powerful idea to chew on. The first wave of AI, the brute force era, proved what was even possible by just scaling things up. But the next great leap forward, it might not come from building even bigger machines. It might come from designing much, much smarter ones. The real question now is, if this next generation of AI is built on efficiency, not just raw power, what incredible new things will it allow us to do?